For the third part, it's the MLAG networking configuration. So first we need to know what is the MLAG. The MLAG, its full name is the multi-chassis link aggregation group. That is across devices link aggregation group is a mechanism that can implement cross devices link aggregation. It integrated devices and to other devices across devices to make the link reliable. So the performance has been improved from the single board level to the equipment level, forming a dual active system. So how to understand this? Um, Yesterday we have talked about the link aggregation, LACP, right? LACP in the Cisco it called the internet trunk. Uh, this is for in one switch and to aggregate the ports together, right? But for the MLAC, it means it can aggregate the ports from the multiple devices. Uh, from the picture, you can see there is three there is a three switch, and we can make the MLAC and to aggregate the ports from the switch 1 to the switch 2. Aggregate the port from the different switch together, just like the LACP. So what's the advantage of the MLAC? The first is the high availability. You can improve the link availability from board level to the devices level. Also, it can simplify the networking and the configuration. The MLAG can be understood as a horizontal virtualization technology that can locally virtualize the two devices into the one device. MLAG provides a layer 2 topology without loops while implementing the redundant backup. And also it can support the independent upgrade. The two devices can be updated separately to ensure that one device is working normally, which has almost no impact on the running devices. So after we make the MLAC, we can upload the K devices, and without the we can upgrade the devices without disconnect. Here is the topology of the MLAC. For example, the switch A connect to the internet, and the switch B also connect to the internet. We make the MLAC between switch A and switch B to aggregate the port from switch A and the port from switch B together. For the MLAC, there is some name you need to remember. The MLAC master, normal, and the MLAC backup, MLAC ID. For the MLAC ID, we need to keep keep the ID same for the master and the backup, just like the VRP. Also, we need to connect the peer link port between the two devices, between the master and the backup. And for the peer link port, it should be the layer 2 port. Also, For the keep alive ports, it should be the layer 3 ports. For the keep alive, it's a heartbeat link and sends the heartbeat message. The main use for the keep alive is for the multiple master detection. Okay, some for the other information, you can check the PowerPoint later. So after the two MLAG devices are configured, the two devices will periodically send the MLAG negotiation message through the peer link, and after receiving the MLAG negotiation message from the peer, it will try to determine whether the MLAG ID in the MLAG negotiation message is the same with the local end. So if this MLAG ID is the same, after compare, if it's the same, okay, we can join in the one MLAG group. And after the pairing is successful, the two devices will determine the active and standby status by comparing the priority. So when you the MLAG system, they use the MLAG ID to decide whether whether the devices are in the same MLAG group. And after the pairing in the same group, they need to confirm which one is the master by comparing the priority. The priority with the smaller the priority number is, and the high availability, the high priority it is. So after the master and the backup negotiate, the two devices will periodically send MLAG a heartbeat message through the network site. So when both devices can receive the message can send by the peer, the active system will start normal work. After normal operation, the two devices will send MLAG synchronization message through the peer link to synchronize the peer information from in real time. The information includes the MAC entries, the ARP entries, etc. A device's failure will not affect the forwarding of the traffic to ensure the normal business will not be interrupted, because when the master devices has the system failure, it will send the message to the standby devices and by the peer link, and the standby devices, after comparing the priority, he will find his priority now it's more higher, and then he changed to the master to transfer the data, and this action it's in a short time. For the unlike traffic forwarding mechanism, the unicast traffic from the non-MLAG member interface. For example, the unicast from the switch D to the internet. The switch A will forward it directly for the unicast traffic normally. For the unicast traffic from the MLAG member interface, it will be the load balance. Switch A, for example, the traffic from switch C, it will be load balance to from flow by flow load balance to switch A and switch B, and switch A and switch B will send the traffic to the internet. Next is the multicast or broadcast traffic from non-MLAG interface. For the broadcast or the multicast, for example, the switch D, the traffic, the multicast from the switch D, when it arrived in the switch A will also uh, multicast this message to the internet side, and also will send to the switch B by the peer link port, and also will multicast the message to switch C. But when the message arrived in the switch B, it won't send back to the switch C because there is the peer link port isolation mechanism. So all the traffic received from the peer link port will not be sent out from the MLAG dual homing member port again. So switch B, after receives the packets from the peer link, it won't send it back to switch C. It will send the multicast message to the other devices. The next is the multicast or broadcast traffic from the MLAG interface, from the MLAG member interface. For example, the traffic from switch C will sent by switch A and switch B with load balance. Here, clarify the traffic forwarding route based on the switch A. The switch A receive the traffic and send to the next hop. Since the peer link ports and the MLAG member interface has the one-way isolation mechanism, so when traffic arriving at the switch B also it won't forward the traffic back to switch C. It just send it to the next hop. For the unicast traffic from the network side, the traffic from the network side will also be sent by the load balance. For unicast traffic sent from the network side to the unlike member interface, the traffic will be load distributed to switch A and switch B, and then sent to switch C. And for the traffic to the switch D, for the network side, the unicast traffic designed for non-unlike member interface. Now here we just take the switch D as an example. The traffic is not load shared because the traffic is from the network side to the non-unlike member, and it's the unicast, so it will be directly sent to the destination. For the multicast broadcast from the network side, here we also take the switch A as an example. The network side traffic, multicast traffic, sent to arrive at the switch A, and the switch A will send it to the next hop. It also, because the peer link exists, so it will also send the multicast traffic to the switch B. After switch B get the traffic from peer link, it won't send to the MLAG member, since the one-way isolation mechanism. For the traffic forwarding, when the peer link fail, but the keep live link runs normally. So at this time, all the ports will be error down in backup, and in backup switch, except the management port and the peer link port and active port, the ports in unlike master still up. So when once the peer link recover from the failure, the ports in error down state will be up in 120 seconds by default. Uh, this one means if, for example, we have already configured the MLAG between switch A and switch B, but the devices already start normally. The MLAG already working normally. But at this time, I just unplug the peer link, and this time, and then the switch B as a backup, he will arrow down the ports, the peer link ports, and he will arrow down the ports except the management port, peer link port, and the keep alive port. Other port will be arrowed down. And when you connect it, it will restore. And for the traffic forwarding when MLAG master device is failure, the MLAG master device is failure, and then the backup devices will become the master. The link status on the device slide is still up, and the traffic forwarding status remains unchanged. The traffic still be forwarded, and the link status of the MLAG master devices becomes done. After the failure of the MLAG master devices is restored, the MLAG devices that was upgraded from the backup stage to the master stage will still maintains the master stage, and the restored master devices will become the MLAG backup device. For the traffic forwarding, when the downlink failure, the MLAG master and the backup states will not change, and the traffic is switched to another link for forwarding. The failed link status becomes down, and the dual homing scenario becomes a single homing scenario. If the uplink failure, when the dual homing access to common Ethernet network, the heartbeat packets are generally sent to the management network. So it doesn't affect the heartbeat detection of the MLAG master devices, and has no effect on the active system. So switch A and switch B at this time will still keep forwarding the data normally, as shown in the figure. Due to the uplink failure of the MLAG master devices, the traffic passing through the MLAG master devices is forwarded through the peer link. The next is about the configuration. So about the MLAG configuration, here is an example topology map for the configuration. For the fight mode MLAG configuration, please note that for MLAG, maximum support 2 smart switch in one MLAG system. We also need to configure the MLAG ID. In FATIP mode, need to configure MLAG ID to make MLAG system, and the MLAG ID must be the same for both two switch. And for the priority, just now I have explained. The priority number is used to confirm which one is the master, which one works as a backup. The switch with the lower priority will be the master. And when the priority number are same, need to compare the switch MAC address. the smaller the MAC address, the higher the priority. In the normal situation, the keep alive port never forwards any MLAG traffic. It only used to detect whether there are two master switch when the peer link recover from the failure. And also, for the keep link port must be the layer 3 port. As port, if it can be not connected, just according just in the actual scenario. And then we need to configure the peer link port. The peer link port is used for sending the negotiation and the synchronized message between master and the backup devices. This port is essential. You must connect the two devices with the peer link port, and this port must be the layer 2. Also, the ports, if we make it as the peer link port, and it cannot be used for the other business. When the link of the peer link port failure, in order to prevent the loops, the service ports of the backup devices were forming the MLAC are automatically closed. So you can exclude some service ports from being closed by excluding the ports. For example, that port is connected to the FTP server when the problem happen, and you don't want this port to be closed, so you need to exclude these ports. After the peer link recover from the failure, the service ports that automatically shut down before will automatically recover after 100 to 20 seconds by default. For the recovery time, you can set by your own. For MLAG configuration, it's the same with the link aggregation, only supports the layer 2 link aggregation. The trunk ID in master and the backup should be the same. For the FATE modes, we go to the switch management center, switch management. First, we need to configure the peer link port. So we go to switch management, the ports. As we know, the peer link should be the layer 2 ports. So here we change it to layer 2 and make it as a trunk. And the keep alive port, it should be layer 3 interface. So we configure the port before. And the second, we go to the high availability to new the MLAG. MLAG now support 2 switches in one group. We need to set the different priority for each switch. In this MLAG group, we choose the 2 switch, and for the 2 switch, we give it 2 different priority. The master switch is with the small number of priority. When the priority number are the same switch with the smaller MAC address will be the master. And then we need to configure the peer link port. The logic for the config MLAG is the first you make a VIP group, and then you choose the 2 switch in the first you configure you knew the MLAG group, and then you choose the 2 switch to add it in the group, and then you choose the 2 ports from the switch and make it as the peer link port, or make it as the keep alive port. After you choose the peer link port and the keep alive port, and then we just choose the port to exclude the port. to choose some ports which are the excluded ports. It means when the peer link down, the switch will automatically disable the other ports, but for these ports, it will be excluded. After we configure the ports, yeah, after we configure MLAG member ports, only after we config the MLAG member ports, the MLAG only supports layer 2 link aggregation. After this one, after all of this be configured, and then we click save. After we save the settings in the high availability MLAG, now we can see that there is one item. The description is MLAG between switch 3191. This is MAC address. There you will find that there is two switch in this MLAG group. And in the switch status, we can see that these two switch already in the MLAG group, and it already be aggregate together.